This is section 3.4, and we're talking about how we prove lines, how we prove that lines are parallel. So on our graphic organizer, on the other side of the graphic organizer, all of the information that we had there was if we know that the lines are parallel, what do we know about the angles? Today we're talking about we don't know, to start with, we don't know that the angles are parallel. How can we prove that they are? So that's what the point of today is. If we don't know the lines are parallel, how do we prove that they are? So on the other side of our graphic organizer, the very top box, it talks about corresponding angles. And on Friday when we talked about these parallel lines, we said that that was our postulate for today. So this part doesn't go on our graphic organizer for today. I'm kind of restating, saying again what we talked about on Friday. So on that big middle box on the other side of the graphic organizer that we already filled in, we talked about our corresponding angle. We called it our postulate. So I'm going to write that out in a little more detail because we're going to use the corresponding angle postulate to start today. So we said that box on the other side that we already filled in was our postulate, and it's called the corresponding angle postulate. And just another reminder, what did we say? What do we mean when we are talking about a postulate? Something that we believe it to be true, we accept as true without proof. So our corresponding angle postulate says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So I'm just writing out what's in our box on the other side of our graphic organizer just in a little more detail. Corresponding angles are congruent. So what we're going to do today is we're going to work with the converse of this postulate. So let's write the converse of this. So if we have an if-then statement, a conditional statement, how do we make the converse? What do we do to it? We flip the if and the then. We just turn it around. So let's write the converse of the corresponding angle postulate. If, what would go first now? If, Angelique? Sure. Almost. So we're going to say if corresponding angles are congruent, so that part was fine. Then two lines cut by a transversal are parallel. So our converse tells us if we know that corresponding angles are congruent, the two lines cut by a transversal are parallel. We can't prove this yet. We will be able to. But for today, we're going to say this is our postulate for today. If corresponding angles are congruent, then two lines cut by a transversal are parallel. So that lets us fill in our box on the upper left-hand side. It says using corresponding angles. So if we don't know that these lines are parallel, if we don't know that line M and line N are parallel, we want to know how can we prove that they are. So in the upper left box, it says using corresponding angles. So to use corresponding angles, we can say that if, and this is the part that goes in your box, if angle 4 is congruent to angle 8, or angle 3 is congruent to angle 7, or angle 1 congruent to angle 5, or angle 2 congruent to angle 6, then the lines are parallel. So this is the information that goes in your corresponding angles box in the upper left. If any of these angles, angle 4 and angle 8, 3 and 7, 1 and 5, 2 and 6, if any of those are congruent, that guarantees us that the two lines are parallel, because corresponding angles are congruent in that case. So that's one way we can prove lines are congruent. We know the corresponding angles are congruent, then the lines have to be parallel.
So if one parallel and all of them
You mean if they're congruent?
yeah.
Right, so if one pair is congruent, that guarantees that the lines are parallel, and then that makes all of the corresponding angles congruent. So all of these would match up in pairs like this.
So if I had a problem and I found out that one is parallel, I could just, that's my answer right there. That's my answer.
Well, the problems would say, how do you know that these two lines are parallel? And if you knew that angle 1 and 5 were congruent, you'd say they're parallel because corresponding angles are congruent. And that would be all you'd have to do. Okay? And then the problem might ask you, like our opener, okay, now figure out what the angles are, and then we just do them like we've done our openers. Okay? All right, in the next box down, it says using alternate interior angles. So this is the next box down on the left-hand side. So this is another way we can prove that the lines are parallel. If angle 2 is congruent to angle 8, or angle 3 is congruent to angle 5, then the lines are parallel. So if we start out not knowing the lines are parallel, if alternate interior angles are congruent, excuse me, then the lines are parallel. 2 and 8 are alternate interior angles, and 3 and 5 are alternate interior angles. And that information, again, where those angles are, you can get from, you can look at the other side of your graphic organizer, figure out how we name those angles. So now we have two ways to show that lines are parallel. If we know that corresponding angles are congruent, then our lines are parallel. If we know that alternate interior angles are congruent, then we know that the lines are parallel. On the upper right side, it says using consecutive interior angles. Consecutive or same side interior mean the same thing. Now from the other side of our graphic organizer, if the lines are parallel, what did we say we could tell about same side interior angles? The answer is on the other side of your graphic organizer. They're supplementary. If the lines are parallel, those angles are supplementary. So we're just going to turn that around. If the measure of angle 3 plus the measure of angle 8, the same side interior angles, if they add up to 180 degrees, or the measure of angle 2 plus the measure of angle 5 equals 180, then the lines are parallel. So if we know that the same side interior angles or consecutive interior angles are supplementary, they add up to 180 degrees, then the lines are parallel. That's another way we can show that lines are parallel. If we know that these angles add up to 180 degrees, that guarantees that our lines are parallel. So now we have 3 ways that we can prove that lines are parallel. In the box below that, alternate exterior angles. So on Friday, what did we say we know if the lines are parallel? What do we know about alternate exterior angles? Alternate exterior angles, if the lines are parallel, alternate exterior angles are congruent. We're just turning that around. And we're going to say that if angle 1 is congruent to angle 7, alternate exterior angles, or angle 4 is congruent to angle 6, then the lines are parallel. So if we know that alternate exterior angles are congruent, that guarantees us that the lines are parallel. So this is a 4th way that we can show that 2 lines are parallel, if we know that alternate exterior angles are congruent. Now, they kind of left one out that I want to add in just below alternate exterior angles. I'm going to say consecutive exterior angles. So this can just go below alternate exterior angles. So when lines are parallel, what do we know on the other side of the graphic organizer? What do we know about consecutive or same side exterior angles? What is our supplementary? You knew they weren't congruent, but they're supplementary. So we're going to turn that around, and we're going to say that if our same side exterior angles, one in measure of angle 1 plus a measure of angle 6 equals 180, or on the other side, measure of angle 4 plus the measure of angle 7 equals 180, then the lines are parallel. So we have 5 different ways that we can show that 2 lines are parallel, just by figuring things out about the angles. Now our homework and problems like these, a lot of times they'll ask you give a reason why the lines are parallel. And the reason would be something like alternate exterior angles, alternate interior angles. So it's just asking you, what angles do you know that match up with our reasons? Corresponding angles. So that would be a reason why the angles or why the lines are parallel, is because corresponding angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. Those would be our reasons. So basically all they're asking for is give a name to the angles that come from our graphic organizer. So questions on that part? Are you with us, Lyndon? Are you with us, Lyndon? All right, so let's look at the very bottom. The bottom two boxes on our graphic organizer. So on the left, we have a picture that looks like this. We need to fix this one a little bit. This is L, M, and N. So this is on your graphic organizer, and we have a box with kind of an arrow like this. At the top of that box, it should say line L is parallel to M, and these two lines mean parallel. That means that these two lines are parallel, and line L is parallel to line N. It has M twice on your graphic organizer. The second one should be N. So change the second M to an N. So L is parallel to M, and L is parallel to N. If that is the case, then M is parallel to N. So if one line is parallel to two other lines, then those two lines are parallel to each other, is what that's telling us. And these double lines again mean parallel. So this that needs to go away, please. And then in the box on the right, our picture looks like this. Our picture is okay again on this one. And this is line L, this is line M, and this is line N. And our picture looks like so. And we have an arrow, a box with kind of an arrow. This should say L is perpendicular to M, and L is perpendicular to N. So this on your graphic organizer, it has M twice. The second one should be N. And this symbol means perpendicular, and perpendicular means 90 degrees. They make a 90-degree angle. So if L is perpendicular to M and L is perpendicular to N, then M is parallel to N. So this just gives us two other ways to figure out that lines are parallel. If they're each parallel to a third line, then our lines are parallel. And if they're each perpendicular to a line, then our lines are parallel. So we have a bunch of ways now that we can prove that two lines are parallel. Any questions on the graphic organizers? Let's look at this picture really quickly. And if these are our two lines, what kind of angles did we call these on the other side of our graphic organizer? Not 90 degrees, but what angle, same side interior, alternate exterior, what kind of angles would we call these two angles? They're each above the transversal to the right of the lines. What do we call those kinds of angles? They're 90 degrees, but they're a certain kind of angle with our parallel lines. Same side interior, same side exterior, alternate interior. What kind of angles would those be? Anyone?
Yeah.
These are corresponding angles. So this works because corresponding angles are congruent. Our corresponding angles are 90 degrees. All right, what I want to do next, this isn't on as part of your graphic organizer, but I would suggest that you write this down in your notes. I want to do a quick proof about parallel lines, just so you see how proofs with parallel lines work. We're still going to be doing proofs, we're not going to emphasize it quite as much as we did in the part of chapter 2, but we still will look at proofs. So I just want to show you one that has to do with parallel lines. So for this proof, we have two lines, and here's my transversal. I'm going to call this angle 1, this angle 2, and this angle 3. So what we're going to do is prove that if alternate interior angles are congruent, then the lines are parallel. We said our postulate for today was if corresponding angles are congruent, then the lines are parallel. So we're going to say that we're starting from that postulate. We don't know that any of these others are true yet. We start with a postulate and we have to prove everything else from our postulate. So we're going to prove one of our theorems from today using that postulate. So we're given that angle 1 is congruent to angle 2. We want to prove that, we'll call this L1 and that L2. Prove that line 1 is parallel to line 2. So we're going to give a statement. I put too many T's there. And a reason. And this is a very short proof. I would recommend that you write this down in your notes just so you have an example of doing a proof with parallel lines. So I'm going to start by saying angle 1 is congruent to angle 2. How do we know that? Here's your hint. How do we know that angle 1 is congruent to angle 2? It's given.
Yeah.
So our first reason is given. Now I'm going to say that angle 2 is congruent to angle 3. How do we know that those two angles are congruent? What kind of angles are these two?
Vertical angles.
Vertical angles, very nice. So these are vertical angles. So we're almost done. Now I'm going to take this and say angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. So I'm going to say angle 1 is congruent to angle 3. So I'm putting these together in a chain. What was our reason when we put things together in a chain? One is congruent to 2, 2 is congruent to 3, so 1 is congruent to 3. Because it's congruent to 2, we gave that a special name. It was a property. Anybody remember? Not transversal, but transitive. There we go, very nice. You had the first 3/4 of it. This is the transitive property. So I'm just going to say transitive. Now finally, let's look at angle 1 and angle 3. So looking on the first side of your graphic organizer, the side that we finished on Friday, what did we call angles that line up like angle 1 and angle 3? Yes, they are corresponding. So I'm going to say that line 1 is parallel to line 2 because corresponding angles are congruent. Angle 1 and angle 3 are corresponding angles, That was our postulate, that if corresponding angles are congruent, then the lines are parallel. So this is our proof. We're given this. These two are congruent by vertical angles. These two are congruent by transitive. These are corresponding angles, so that guarantees that our lines are parallel. So this would be the type of proof that you would do using parallel lines. I just wanted to do an example of that. Questions? All right.